All right, today we get to look at multiplying decimals. Okay, so make sure that you're on your 3.3 video notes page, and we'll talk about multiplying. I went ahead and typed up the rule since I can't write very well with my pen here. So copy this down on your notes page. I like to say that we're ignoring the decimals to begin with because I do not need to line up my decimals. I'm just going to have all these zeros that I don't need. Next, we're going to multiply like normal. Okay, then we are going to count the place values that are behind the decimal in both of our factors, and then we're going to move the decimal that many times in our product. Okay, so a lot of math words in that definition, so let's see what that's going to look like. So the book usually writes down this type of problem horizontally, so let's do the same. So I have 7 and 1/10 times a negative 0 and 21/100ths. So I do have a negative. I don't want to forget about that, but at first we're going to focus on our multiplication rule. Okay, at first it says to ignore the decimals. So if I ignore the decimals, I have 71 times 21. Okay, and it says to multiply like normal. All right, so go ahead and multiply that out. 0 for a placeholder. All right, so I multiply and I add my numbers. All right, so now I have 1,491. But if I have 7 times something less than 1, I know that is way too big. So now I need to go back and see what my other part was. Now I need to count the place values right of the decimal in both factors. So here I have 1, 2, 3. Okay, I had 1, 2, 3. I have 3 place values behind the decimal. So last step is to move the decimal left that many times in the product. So naturally the decimal's at the end, so that's why it's to the left. We're going to go left 1, 2, 3. All right, why did I move it 3 times? Because there was 3 decimals in my question, in the 2 factors. So that means my answer is 1 and 491 thousandths. Okay, but what do I not want to forget to do? My negative, right? So if I take a positive times a negative, do you remember the rule for different signs? We get a negative product. All right, so final answer, negative 1 and 491 thousandths. All right, let's go ahead and try one on your own. Okay, so on your own we have 6 hundredths, 0.06 times 3. So that decimal's there on the end. So go ahead and try that on your own. All right, here's what my workspace ended up looking like. Ignore, move the decimal, and then move the decimal in our product. Okay, go ahead and try. This is on your own, take 2. So now I have a negative 2 and 6/10 times negative 4/10. So go ahead and try this one on your own and see how you do. Okay, here's what my workspace ended up looking like. I had 2 place values in my factors, therefore I had to move it 2 place values in my product. All right, now we get to take a chance to practice our U-pick strategy. So example 2 says, student tickets for basketball playoffs cost $9.25 each. How much do 9 tickets cost? So, understand the problem, just restating the question. We just want to know the cost of 9 student tickets. All right, sorry I can't write well with this thing. All right, picking a strategy. Well, if I need 9 tickets and they all cost the same per ticket, so I could do repeated addition, 9 plus 2 $9.25 plus $9.25. But a faster way to do repeated addition is to multiply. Okay, so in our implement strategy, you get to try another one on your own. We're taking our $9.25 times 9. Okay, try it on your own. Okay, here's what my workspace ended up looking like. To place values in my factor means to place values in my answer. My conclusion states that 9 student tickets cost $83.25.